Dear students, under the topic vector differentiation, here we have result 8. This is a very significant result in the examination point of view. It is given that if r vector is equal to xi vector plus yj vector plus zk vector and r is equal to modulus of r vector, then nebula dot r power n r vector is equals n plus 3 multiplied with r to the power n. So now we shall prove this result. So now in order to prove this result, first we should write the identity which gives us nebula dot product of a scalar function and a vector. So let us write that. So we know that nebula dot product of a scalar point function and a vector point function is given by nebula phi dot a vector plus phi multiplied with nebula dot a vector. So we are going to apply this identity in this. That is nebula dot r to the power n will be treated as phi and r vector will be taken as a vector in this formula. Therefore, applying this identity over here, nebula dot r to the power n r vector will be equal to. So first we have to write nebula phi. So what is phi over here? It is r to the power n. So nebula r power n dot product with a vector. A vector is r vector over here plus phi. Phi is what? R to the power n. So r to the power n multiplied with nebula dot a vector. So we will have nebula dot r vector. So we have written this identity. That is, we have applied this identity. So after applying, we have to apply few more identities in order to proceed this further. That is, we have to use nebula, we have to find nebula r to the power n, for which we will be using the identity nebula f of r. We know that it is equal to f dash of r multiplied with r vector. And in order to find this nebula dot r vector, we know that in one of the result we have found that nebula dot r vector is equal to 3. So we are going to apply these two now. So when we apply nebula f of r to be equal to f dash of r cap, we see that at the place of f of r, we have r to the power n. So f of r is what? R to the power n. So what will be f dash of r? The differentiation of r power n, which is n r to the power n minus 1. So let us apply this. So therefore, we will be getting nebula dot of r to the power n r vector to be equal to, first is nebula r to the power n, which when we apply here, it will be differentiation of r to the power n, which we have got as n r power n minus 1 multiplied with r cap. So multiplied with r cap. And then what we have, dot product with r vector plus r to the power n. And what is nebula dot r vector? It is equal to 3. So that we will apply here. Now we know that r cap is equal to what? That is, we know that r cap is equal to r vector divided by r. So we are going to apply this now at the place of r cap. So what we will be getting is, this is equal to n r to the power n minus 1. So instead of r cap, we can write as r vector divided by r dot product with this r cap plus 3r to the power n. Now further simplifying this will be equal to n r to the power n minus 1. What is r vector dot r vector? It is equal to r square. So remember, r vector dot r vector is equal to r square. This also we have seen previously. It's a vector identity. So applying that, what we get here is r vector dot r vector is r square divided by, we have r in the denominator over here, plus 3 to the power, 3r to the power n. So now one of the r gets cancelled, and here we have r to the power n minus 1, and here we have r to the power 1 now. So when we add up, minus 1 plus 1 becomes 0, and so we will be having n r to the power n minus 1 plus 1, which will give us r power n plus 3r to the power n. Now r power n is common in both the terms, and so we will be getting n plus 3 multiplied with r to the power n, taking this r to the power n common out. So therefore we have got this to be n plus 3 multiplied by r to the power n, which is the required result that we have to prove. So we have proved that nebula dot r power n r vector is equal to n plus 3 r to the power n. So hence it is proved. So using this result, now we shall solve one problem under this. And this result has been given as problem number 47 in your prescribed textbook. So kindly make a note of it. So next we will solve a problem now. So the question is, if r vector is equal to xi vector plus yj vector plus zk vector, find n so that r to the power n r vector is solenoidal. So now it is given that that is r to the power n r vector is solenoidal. They are asking us to find the value of n over here. So in order to do that, first we should know what is solenoidal. A vector is said to be solenoidal if nebula dot product with A vector will be equal to 0. So if nebula dot A vector is equal to 0, we say that A vector is solenoidal. So using this concept, now it is given that r to the power n r vector is solenoidal, which means that nebula dot r to the power n r vector is equal to 0. Now the result that we proved just now, from that we obtained that is nebula dot r to the power n r vector is equal to n plus 3 multiplied with r to the power n. So let us make use of this result here. So the result is nebula dot r to the power n r vector is equal to n plus 3 r to the power n. So using this result here, we get, so what will happen, instead of this we can substitute this. So n plus 3 r to the power n will be equal to 0. So from this we can say that n plus 3 is equal to 0, since these two are in product, and n plus 3 is equal to 0 implies that the value of n is equal to minus 3. So therefore we have obtained the value of n given that r to the power n r vector is solenoidal. In our next video lecture, we will derive the results 9 and 10. So kindly follow the next video lecture. Thank you.